Okay, so let's begin with a quick overview of the autonomic nervous system. And you should have read the notes by now, so you know generally what the sympathetic system is versus the parasympathetic system. Both of these are the divisions of the autonomic nervous system, which in turn is a division of the efferent nervous system, which in turn is a division of the peripheral nervous system. So let's go over that really quickly too. We have our central nervous system, or the CNS, and the peripheral nervous system, or the PNS. We can divide the peripheral nervous system into two. The afferent division, which would be sensory, and then the efferent division, which would be motor. And I'm exaggerating the way you pronounce the A and the E here so that you can hear me. It's afferent and efferent. So you get the idea there. Now for the efferent then division, being motor, we're going to have two divisions to that. So we've got the somatic motor, which we've talked about before. That's dealing with skeletal muscle. And then we have the autonomic motor, which is dealing with cardiac muscle, smooth muscle, and glands. Then we can divide the autonomic system into two. The sympathetic, or what's called the fight or flight response, or the parasympathetic, which would be the rest and repose system. So for the sympathetic system, you're thinking of, like you're in danger, you're afraid, you're running away, or you're trying to fight off something. So you need to have your heart rate go up, your breathing will be faster, more blood flow to your brain, so your brain actually works faster than what it normally does. You don't need to worry so much right now when you're fighting for your life about digestion or filtering blood to make urine and reproduction and things like that. Those sorts of things are going to be inhibited while you're in the middle of a fight or flight response. The parasympathetic system, on the other hand, this is when you're relaxed. You're not fighting for your life. Nothing terrible is happening to you. So your heart rate doesn't need to be so fast. Your breathing doesn't need to be so fast. You don't need to be as sweaty. Sweat is also a part of the sympathetic system. You're just more focused on digestion, filtering the blood, so more blood flow to the kidneys, digestive system, reproductive organs, all those things that aren't, of immediate concern when you're in the middle of fight or flight. Now you can work on doing those sorts of things. Now, you're never, or rarely, are you all one or the other. It's a balance. So say, you're listening to this lecture, you're probably some sort of alert. Hopefully you're some kind of alert. So you got a little bit of sympathetic, maybe you're a little nervous about learning about the autonomic system, so you're getting like a little anxious about that, so that's a little bit of sympathetic. And then you're like, oh wait, that makes sense. So the parasympathetic kind of takes over a little bit more and you feel a little bit more relaxed. So there's always a balance between those, and it's just always responsive to whatever's going on. So there's a difference in how these two are arranged just physically in the body and what neurotransmitters are used for the sympathetic system versus the parasympathetic system. So that's where this picture comes in, like a compare and contrast. For both of these, we have just a rudimentary drawing here of the brain and the spinal cord, and then an effector out here, which will be the heart, just as our example, so cardiac muscle there. Now both systems are going to have an upper motor neuron, that would be what's in the blue, and both systems will be having a lower motor neuron, that would be this like darker red color here. So we're just looking at where they are, where these neurons are, and what neurotransmitter they're releasing to communicate with the next step. So between the upper motor neuron and the lower motor neuron, what the receptors will be on the lower motor neuron to receive that neurotransmitter, and then what is the neurotransmitter that the lower motor neuron sends out to the effector, and what are the receptors that the effector has to receive that neurotransmitter. So let's start out with the sympathetic system. Actually, let's do both at the same time. At first, where they're exactly the same, because the upper motor neuron is going to be in the same place. It will be in the brainstem. We talked about this before. The pons or the medulla oblongata, somewhere deep in the brain, could possibly be in the anterior horn of the spinal cord, but mostly in the brainstem. And that upper motor neuron's axon will go down through the spinal cord. It'll go out through the ventral root of the spinal cord. We're going to get more into detail on that within a couple of videos here, not for this one. But we already know the ventral root of the spinal cord. There's going to be a little bit more to it than that, but we know that the ventral root of the spinal cord is for motor neuron axons. So out it goes through the ventral root of the spinal cord. Okay, now let's just go back over to the sympathetic system. So our axon has left the ventral root of the spinal cord, and it has met up with the lower motor neuron that's found in an autonomic ganglion. And this would be a sympathetic ganglion in particular. We're going to learn about those different ganglia next video. So this upper motor neuron, it has an action potential. It releases acetylcholine into the synapse. On the lower motor neuron, we'll have nicotinic cholinergic receptors. So we know about these. We learned about these for the last unit. When acetylcholine binds to a nicotinic cholinergic receptor, that causes ion channels to open. And the ion channels that are opening are sodium channels. In goes the sodium. We have a depolarizing gradient potential that leads to an action potential in the lower motor neuron. The lower motor neuron then goes out to the effector. Its synapses here with the heart in this case, and it's going to release epinephrine or norepinephrine. Those are the adrenalins. You know, when you think of the sympathetic nervous system and fight or flight, you think of adrenaline. That's epinephrine and norepinephrine. And we know that if we're releasing epinephrine or norepinephrine, we have to have adrenergic receptors. Depending on what the effector is, could be any one of those adrenergic receptors, alpha 1, alpha 2, beta 1, beta 2. In the case of the heart, it would be beta 1. So we don't need to go back into all that, but it would be a beta 1 adrenergic receptor here that will stimulate the heart to beat faster. So that's the sympathetic pathway. For the parasympathetic pathway, you'll notice that the axon for the upper motor neuron, I made it much longer. And the reason for that is that the lower motor neuron, which is still an autonomic ganglia, but this time it's in a parasympathetic ganglion, and it's in something that is called a terminal ganglion, which can also be called an intramural or an intrinsic ganglion. These are ganglia that are very close to the target organ or even in the target organ. So that's where the parasympathetic lower motor neurons will be way, way out close to the effector, where the sympathetic lower motor neurons are going to be very, very close to the spinal cord, right next to the spinal cord or just in front of the spinal cord for the most part. There are some that are out in these terminal ganglia also, but mostly they're in these ones that are closer to the spinal cord. So here's our upper motor neuron going out through the ventral root, and then it goes on out through various pathways, out finally to the terminal ganglia here, where we will meet up with the lower motor neuron. Now in that ganglion, that upper motor neuron is going to release acetylcholine, just like it did over here in the sympathetic system, same neurotransmitter. And on that lower motor neuron, we're going to have nicotinic cholinergic receptors, just like we had over here in the sympathetic system. So it's the same. It's exactly the same so far. So we bind our acetylcholine to those nicotinic cholinergic receptors, open the sodium channels, in comes sodium. Depolarizing gradient potential stimulates the lower motor neuron to have an action potential, and then when it does, that lower motor neuron releases acetylcholine. Neurotransmitter here in the parasympathetic system is typically acetylcholine. This is different. In the sympathetic system, it was epinephrine or norepinephrine. Now it's acetylcholine. So we're going to need cholinergic receptors on the effector again, and this time they'll be muscarinic cholinergic receptors. Okay, so that's the only difference. What type of neurotransmitter is being used at the neuroeffector junction, and what sort of receptor we're using there as well.